Hello and welcome to Algebra 2, Chapter 5.6, the quadratic formula and the discriminant. And this is going to be the last of our ways to solve a quadratic. Remember, we have solving by graphing, which only really works if you have integer answers, or it estimates your answers. We had solving by factoring, which only works if something is factorable. Solving by taking a square root, which only works if you have an x squared or a quantity like binomial squared. Solving by completing the square, which works best if you have a leading coefficient of 1, and if you don't, you have to divide by that leading coefficient. And so this now is using the quadratic formula, which works for any quadratic no matter what. So here is the quadratic formula, and the first thing that you need to know is that you need to have your equation in standard form, which is going to be ax squared plus bx plus c equals 0, so it is descending order, has to be equal to 0, and to solve for x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so you figure out what your a, b, and c are and you plug them in where they go. You are going to need to have this memorized, and from this you can get two real answers, you can get one real answer, or you can get two imaginary answers. And so since there's several cases, we're going to do a few examples, but at any time if you need to fast forward, feel free to. So here's our first example, 3x squared plus 8x equals 35. And it has to be equal to 0, so the first thing you need to do is subtract 35. And we're going to do 3x squared plus 8x minus 35 equals 0. And I would suggest that, at least to begin with, you write out what are a, b, and c. So in this case, a is 3, it's your coefficient on the x squared. B is 8, your coefficient on the x. And c is a negative 35, it's your constant. And I would even in the beginning, if you don't have the quadratic formula memorized, I would write it out. Negative b plus or minus the square root of b squared minus 4ac all over 2a. I think the best way to remember things is to keep writing them out, and it might seem awful, but I think it helps. So we're going to plug in our numbers. So we have a negative that comes with the formula. B is 8 plus or minus the square root of 8 squared minus 4 times 3 times negative 35, and that's under the square root, all over 2 times 3. My next step is that I would simplify what's under the square root, so we're looking at 64. And then if we take, I would consider that a negative 4 times 3 times negative 35. It's going to be a positive, so plus 420. All over 6. So our next step then is negative 8 plus or minus the square root of 484 all over 6. I'm going to check to see if 484 has a square root, and it does. It is 22. Okay, so all I did was take the square root. Now there are two answers here, so you need to go one step further. So we're going to do x equals. So you're going to do negative 8 plus 22, which is 14, and 14 divided by 6, let's see here, so you can get 14 over 6, which is going to be 7/3, and then you're going to do negative 8, let's do this way, negative 8 minus 22, which is going to be negative 30, and you're going to divide that by 6, and you get negative 5. So if you get an answer that looks like this, you need to take it one step further because this is math that you can actually work out. So we're saying that it doesn't have a radical sign in it. Okay, so let's try that again. Now the great thing about the quadratic formula is that this is really the only one that a can be negative on. So just to show you, it has to be equal to 0. So if you want to move everything, actually, I went ahead and did the opposite, didn't I? Okay. I'm moving everything to the right because by habit I always make things positive, but you could, if you wanted to, move everything to the left, in which case your a would be negative and it would just change all your signs, and that's fine. That's just one sign there in the middle. Okay, so A is 2. B is a negative 12 that I forgot to put the 1 back in. And C is 18. And then I really do suggest that you write out the quadratic formula. Okay, and then you plug in things. So we have a negative that comes with a quadratic formula, but I'm putting in a negative 12. So then I have a negative 12 squared. Definitely put that in parentheses. Please, please, please put that in parentheses. All over 2 times 2. You know, and if you went the other way and moved everything to the left, you're going to get the same answer at the end. So this is going to be a positive 12 plus or minus the square root of a positive 144 minus, because it's a negative 4 times 2 times 18 minus 144 all over 4. So the last example we had 2 real answers. This example, I now have a 0 there. Well, what's the square root of 0? It is 0. Is there any reason for me to do plus or minus 0? There's not. So that goes away. X equals 3. In this case, you only have one answer, and that one answer would mean that your vertex is on the x-axis. Alright, moving on. Okay, let me see if I can make this one have a negative a. If we move everything to the left, then we're going, that's a negative 2x squared plus 2x minus 3 equals 0. So in this case, a is negative 2, b is a positive 2, and c is a negative 3. And if you moved things to the other side, that's fine. Okay, so we're going to have negative 2 plus or minus 2 squared minus 4 times negative 2 times negative 3 all over 2 times negative 2, which is negative 2 plus or minus the square root of 4 minus, because I have a negative times a negative times a negative, right? So negative 4 times negative 2 times negative 3 is a negative 24, so minus 24 all over negative 4. So this is going to be the third situation you're going to run into, and that is we have a negative under the square root. So we now have a complex answer, because we're going to have an imaginary number. So we need to simplify our square root first of all. So we have the square root of 4, square root of 5, and yes, there's a square root of negative 1 in there. So let's look at this as negative 2 plus or minus 2i square root of 5 all over negative 4. And then we're going to look at the 2, and the 4, and do they all reduce? Yes. And so we're going to reduce them all by 2, and so this is going to be negative 1 plus or minus I square root of 5 all over negative 2. We're just going to leave it just like that. Why don't you pause the recording and see if you can work this one out, and then play it back and see if you get it correct. Alright. So I got 1 and negative 4. Do remember, if you get, square root of 25 can be simplified, and so if you get something like this, that goes further. So that's not your answer. This over here is your answer. Okay? And also remember, you can always plug these back in and check them, and they should work giving you 0. So one more time, if you need some more practice, why don't you go ahead and pause the recording and see if you can do this one. Okay, a few things to remember. You remember, if you're putting in a negative for b, you have minus a negative, which is going to turn positive. The other thing underneath when you're putting in a negative for b is definitely put it in parentheses so that when you square it, it turns positive. In this case, we had a negative 16 under the square root, which simplifies into 4i. And then I just simplified the 2 and the 4 by 2, and you get 1 plus or minus 2i. So the next thing we need to talk about is the discriminant. And sometimes you want to know what type of answer you have without solving it. You know, does this cross the x-axis twice? Does it not? And so the part under the square root is called the discriminant, the b squared minus 4ac. And you calculate just that part. You don't put it under the square root or anything. You just do the b squared minus 4ac. If it turns out to be positive, you're going to have 2 real solutions. If it turns out to be 0, you're going to have 1 real solution. And if it turns out to be negative, you're going to have 2 imaginary solutions. And so we've done those 3 types of examples already. And so this just tells you what type of solutions you're going to have. So let's find the discriminant of these 3 quadratic equations. And remember, they still have to be in standard form equal to 0. And so we're looking at b squared minus 4ac. So in this first one, a is 9, b is 6, c is 1. And so b squared would be 6 squared minus 4 times 9 times 1, which is going to be 36 minus 36, which is 0. So it's going to have 1 real solution. Okay, and notice it says give the number and types, so 1 real. So the next one, a is 9, b is 6, c is negative 4. So we're going to have 6 squared minus 4 times 9 times negative 4, which is 36. And then negative 4 times 9 times negative 4 is plus 144. And that is a positive number, and it's actually a positive 180. So this is going to have 2 real solutions. Okay, and I am going to be looking to see that you have the discriminant as well as the 1 real, 2 real, or 2 imaginary. So make sure you have the work as well as the answer. So the last one, a is 9, b is 6, c is 5. By the way, c is not always 6, or b is not always 6. B squared minus 4 times a times c. So this is 36, and then negative 4 times 9 times 5 is a negative 180. That is going to be a negative answer, negative 144. And because it's negative, we're going to have 2 imaginary solutions. Alright, I got one word problem left for you. The water in a large fountain leaves the spout with a vertical velocity of 30 feet per second. After going up into the air, it lands in a basin 6 feet below the spout. If the spout is 10 feet above the ground, how long does it take a single drop of water to travel from the spout to the basin? Okay, and it says to use this model here. And so let's look. So h is a final height. So when it returns to the basin, what is its height? Its height is 0. Alright, so the negative 16, and we're actually looking for time. How long does it take? So t stays t. V naught, or v sub 0, is your initial velocity, which is going to be 30 t, plus h naught, or h sub 0, is your initial height. And let's see here. We really don't want to use the 10, so let's sketch out this situation real quick. The basin, okay, so if here's the spout, there's a basin that's going to catch it, and that is 6 feet below the spout, so the water is going up and then coming down. If the spout is 10 feet above the ground, so the spout is 10 feet above the ground, but that doesn't really matter because it's stopping in this basin. So we're going to say that the initial height is 6, and we're only going to consider this part of the problem. Okay, because the water is only coming 6 feet below it. So here what we have, a quadratic equation, and honestly, you could try factoring if you wanted to. You could do completing the square. You can do whatever you want, but since we're in the quadratic formula section, we're going to go ahead and try it with that. So x equals negative b, negative 30, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So negative 30 plus or minus the square root. 30 squared is 900. And it's going to be plus because I have a negative 4 times a negative 16 times a 6. So plus 384 all over negative 32, which gives me, let's see here, negative 30 plus or minus the square root of 1284. All over negative 32, and in this case decimals would be fine. You know, you're not going to say what square root of a second it took or whatever. So square root of 1284 is 35.83, and you're going to do negative 30 plus 35.83 and divide that by negative 32. So I get negative 0.182, and then negative 30 minus 35.83. Divide that by negative 32, and we get positive 2.057. Which one of those can be a time? It is the second one, so we're going to put a seconds on the end. That is how long it takes the water to return to the ground. So please post if you have any questions, or email, or come in and see me. And we will see you in class. Have a good day.